You know, I was thinking like how I never look at the camera. Does that ever bother you guys? Like I don't actually look at the camera. It's kind of like not a habit. I almost feel like the autistic part, like I kind of avoid looking at you because it feels a little too intimate, even though you're a camera. It's so weird. It's so weird. Like I should be able to look at you, right? It even feels weird to look at you. I don't get it. God, it's so cold here. I'm just so glad to have a hot tea. All right, let's see if YouTube's working. Looks like it. Let's see if Twitch is working. Looks like it. We're all good. Hmm. Hi, everyone. All right, so today I wanted to do a little bit of Atari 6502 programming. Well, learn more about it, I guess. Because I don't think we've done it. We've done COBOL recently. We did Prologue yesterday. We've done a little bit of Nix. So I feel like we ought to do a little bit of Atari stuff. All of these programming languages, like learning them, stress me out because like all of them, like yesterday with Prologue, it ended up that like the Prologue interpreter I was using actually didn't support the same syntax that the book was giving, and so it was just confusing. And with COBOL, like I'm dealing with an IBM mainframe, and like I'm always getting lost with the mainframe, you know? So it's like I don't actually, sometimes it just doesn't work, and I can spend hours trying to figure out like what's wrong with this stupid mainframe. Like, how do I figure this out so I can actually like move forward? And the same thing with the Atari stuff is like sometimes you're like, oh, go ahead and do this in Atari DOS, and like I don't know how to do it, or something just doesn't work because I don't know Atari. um, yeah, so all of these things stress me out. Like if you do something new, like modern, like Rust programming, you just go to the website, it'll work. Like basically it works. But all this other stuff. And then Nix pissed me off yesterday because like I was trying to do some module stuff with Nix. The next section was like, "Oh, you're going to need a Google account." It's like, "Okay, Google account, fine." And you're gonna need like an API token from Google. It's like, okay. And you're gonna have to put in billing information. So to do this tutorial, I basically have to pay, which sounds kind of like all messed up. So all of these things, like, I'm sure 100% you can go through the Rust book and not have to pay anything. I'm sure you can go through Go, you can go through any modern language and basically like just get the compiler, get the interpreter, and just go through it. But yeah, because I'm interested in these kind of like a little bit weirder things, I guess like I never know before I start streaming whether or not I'm just going to get full on stuck. This is earlier than I'm usually on. How are you guys? All right, so let's get started here. Let me set up. I don't do anything before stream, so it's all just like kind of a mess. Let's get our screen set up here. We're going to be doing Atari stuff. So Atari stuff kind of looks like this. It really doesn't matter. Um, I don't even know where we left off before. But anyway, let's make these sizes a little bit more reasonable. Oh, that's terrible. No one can anyone read that if it's this small? Let's see here. Something like this. maybe like this. There we go. That looks reasonable to me. Alright, so we were doing stuff last time, right? This is all new stuff. We're gonna have to type a lot, I think, on this one. That's right, we're just about to start chapter 7. Okay, so we're gonna be doing Atari 6502 assembly language programming today. We're using the Atari Roots book, so like we're on page 109. So like over here you can see Atari Roots. It's a guide to Atari assembly language. What did I say, 109? And the previous videos we've gone through all the other chapters. We kind of learned how to use the assembler, what bits and bytes are. A lot of boring stuff, and then we got into the CPU with the 65026 CPU, the registers, and we made a little program to add two numbers together. We learned some basic stuff like that. And you can always go back to the Atari 6502 playlist I have on YouTube to kind of like review that. And now hopefully we're going to learn a little bit about looping around and branching out. So these are like control flows within the language. Hey Paolo, how are you? Let's see, do I need to say anything else before we get started? Yeah, so the Atari Roots book, in my other Atari videos, it has links to where you can find this material. We're using the Altira, the thing you see over here on the right. The Altira is a emulator for Atari computers. We're emulating Atari 800 XL with, I think, 64K of memory. And we are using the Mac65 assembler. So we're actually typing it within an Atari rather than coming up with like Visual Studio, upload it to Altira and all that kind of stuff. So that's the setup, and let's just get to it, I guess. Hopefully I don't forget too much of what we were doing. All right, chapter 7, looping around and branching out. Now we're going to start having some fun with Atari assembly language. I guess up until now it hasn't been that much fun, huh? No, I've actually enjoyed it. The first few chapters were really boring, to be honest. They were really boring. Felt like a history lesson and like really remedial math, but like whatever, we did it. In this chapter, you'll learn how to print messages on the screen, how to encode and decode ATASCII, Atari ASCII characters, and how to perform other neat tricks in assembly language. So ASCII is just like an encoding for characters. You probably have heard of it. Actually, I have no idea what it stands for. You think the A is American? Standard Character? Let's look up what ASCII is. That's so weird, right? Where's my browser? Here we go. Let's look up what ASCII stands for. American, I was right. American Standard Code for Information Interchange. Oh, I guess it was for information in general interchange. Kind of makes sense. It's characters, right? So that's cool. The Americans planted the flag on ASCII. We're going to accomplish these feats with some advanced assembly language programming techniques that we haven't tried out so far. I'm not sure how advanced loops are, but yeah. Along with some new variations on techniques covered in earlier chapters. These are some of the programming techniques we're going to cover in this chapter. Using the assembly language .byte directive, incrementing and decrementing the X and Y registers, using comparison and branching instructions together, advanced looping and branching. Oh, I wonder what advanced looping means. Have you ever thought of like, oh, this is an advanced for loop. This is an advanced while loop. Like, it doesn't really make sense, right? Writing relocatable assembly language instructions. Ooh. Before we get started though, I'm going to pull a very sneaky trick. I'm going to ask you to type up and store on a disk a program that you haven't yet been introduced to. I ranted about this yesterday. I hate this. I hate it when they give you code and they say, "Don't worry, you don't have to understand this code. Just write it all up." And it's like, well, can't you sort of build up to it? I hate it. You probably won't understand it unless you've had some previous experience in assembly language programming. I'm asking you to type this program because it contains a couple of subroutines that are needed to run two other programs. Oh God, I'm going to have to type two other programs. Programs that will be introduced and explained in this chapter. The program you may not understand is one that will be explained in chapter 12. Oh my God, we're chapter 7. And they're going to explain the program they're asking me to type up in chapter 12. Okay, that's more than a sneaky trick. That's, you're being a bastard. IO and U. Two good reasons. There are two rather sophisticated but extremely useful subroutines in this program. One is a routine that will open your screen as an output device and put your Atari into its screen edit disk. Screen edit disk. You'll already have that job done the next time you encounter them in IO and U. So I hope you'll look ahead to greener pastures in the last chapter of this book and not be too angry at me for asking you to type this program. I'm totally angry at you. I'm so angry. And why can't you just make it print instead of print? Seriously, it's a label. All right, here we go, guys. We're going to have to type this. God, I hope I remember to save this. Let's check what out. Let me check what disk I have in here. Disk drives. Oh, I have no disks in here. So I like to show you guys when I set anything up like that. So let me switch to desktop mode. And let's see, we go to disk drives. We have nothing here. So we're going to try to load something. And this might be actually the right one, but let's see here. I have ROMs. No, it's one of these. God, I really should make a note which one I'm using. Mac 65 with DOS. I think what we want is the one with Bug 65. Yeah, let's make this disk number 1. And then so when I look into, how do you look in disks? Is it dir D? What? I can't remember any. No, it's list, right? List D1 colon. Oh dear God. This is what happens when you can't remember anything. We made a cheat sheet. Did we actually write anything down? We didn't say how to look up a program by typing dir. So shouldn't this be dir? Or are we not? Dir. Oh, what the hell? Didn't I type that before? All right, we only have one free sector here, so this is kind of like a bad disk to use for this, but maybe it's enough. Maybe we can make a new disk. So we'll do drives, disk drives. Do you remember how to format a disk? Let's see if we can remember how to do that. Yeah, that's kind of annoying because, well, what we'll do is, I think I was using this roots ATR disk. How do I switch to D2? Is it just this? Come on. Dir D2? Dir D2? Seriously? This is one of those things that I just feel like I hate using AI, but it's just a lot easier. Maybe to ask it. No, we don't want this one. What's a decent LLM? Gemini. Now you'll see all my other queries. Alright, so how do I run dir on D2 using Atari OS2A? Is that what it's called? OSA plus. Type D2 then colon. Isn't that, did I not do that? Doesn't work. Is it because I don't have a D2? No, I do have a D2. There's something very funny going on. This is why I always have a problem. Did I not start this stream saying like, hey, I can never figure out. I always get stuck when there's a problem. System enter. I don't think that is what we need to do. What a pain. All right, we're just going to ignore it. We're just going to continue. We'll figure this out next time. Let's go back to Atari roots. That's not good. Here we go. Why are you guys not seeing the same directory? Do I have two Altiras up? One second, this is really confusing me now. Atari. Altira's here. There's two Altiras somehow. Aha! Maybe you guys haven't been seeing what's going on. Maybe this is why it's not working right. Let me just restart Altira. Okay, so we're here. We have disk 1, drives. We have 2 virtual drives. Now if I do D2, it still doesn't like it. Anyway, we'll just try and hope that we can save it in this drive. Max 65420. Oh, we're really screwed. It's like not even... I bet it's because I'm rebooting and basic is on. Let's fix this. I bet this is it. This has to be it. File, It's under File. Where am I not seeing it? It's not here. System, configure system. And under here, disable internal basic. Enable basic boot without options. So we don't want this. We close that off. And now we restart. Aha, look at this. It says D1. I knew it looked weird, right? Oh my God. Hold on. I got to really put this in the browser so that we don't get, I think I probably already have this in the browser actually, but let's check. Yeah, this one over here. Debugging. Something not working. Make sure that make sure basic loading is disabled by default. There we go. Make sure DOS XL disk is in D1. Alright, so looks like I got hosed by this once before because I put it all in caps. So I've called out the section here called debugging when something's wrong. Hopefully we won't get into this trouble again. What a mess, seriously. Okay, so now I can do D2. I can see what's in D2, and now we have plenty of space in D2. This is where we're going to save our data. All right, so let's go ahead and type this program in. So we're going to go back into D1. We see there is max 65420. We run that. Now this is our assembler, and this is where we're going to type our code. So we'll type it in pretty much exactly as they have it. Title, print screen routine. 30 dot page routines for printing. Sorry, they're not overlay. Printing on the screen. Uh-oh, I screwed up. The 20 needs 2 spaces because it is, it's only 1 space for the remark, but for the print screen routine. For compiler, for assembler directives, we need to put 2 spaces, so I'm going to have to retype these. Routines for printing on the screen. All right, so we have that now. We're at 40. 50. 2 spaces because this is a directive. This is saying we're going to start the program in memory address 5000 hexadecimal. 60. Comment. 70. Buff len equals 23. It looks like this is on the first. This looks like it's on the first character, so it's not a compiler directive. 100 EOL is equal to $9B. $sign just means hexadecimal. $105 comment. 110 Now, oh, these are all one space. I hope later it's not, right? Yeah, here it's two spaces because these are actual operations. Okay, so where are we? 110 open is equal to $03. 120 O double or O right is equal to $08. 130 put character is equal to $0b. 135 section. 140 IOCB2, whatever that means, equals $20. 170, we're skipping a whole bunch. ICCOM is equal to $342. 180, and if you see me type anything wrong, please tell me. IC ball is equal to $344. 190 IC BAH, BAH is equal to $345. 200 ICBLL is equal to $348. 210 ICBLH is equal to $349. 220 ICAX1 is equal to $34A. I should just say hex 34A, right? 230 ICAX2 is equal to hex 34B. 235 new section. 240 CIOV is equal to hex E456. 250 new section. 260 screen name dot byte E colon, that's a comma EOL. 270 new section. 280 last one, OCSR, O screen, I guess. Open screen routine. Ah, that's the label. Open screen. O means open. All right. Now we have some code that starts. Load the X register with IOCB2. IOCB2. So we're putting in that number directly, which is 20, right? 300. Load the accumulator with open, and that's 3. 310. Store the accumulator to this address, icom mine, comma x. X is probably 0. No, x is B2, 20. So it's going to take the icom address 342 and jump, add 20 to it. 320, new section. 330, load the accumulator with screen name ampersand 255. I don't know what that does. 340, store accumulator IC ball X. So we're loading whatever this screen name thing is. Maybe this is a bit flag, right? This is probably a bit flag. And then we're putting it into this address. I see about ball X, 340, 350. Load accumulator with the number screen name 256 divided by 256. I'm sure that's not really divided by. 360. Store accumulator into. So what we can see here is there's a lot of like all the numbers, like whenever we want to move it from a memory address to another one, we kind of have to go through the accumulator, which is kind of interesting, right? It's like we can't just say like, hey, take memory address 20 and put it in memory address 40. Like we have to be like, load memory address 20 into accumulator, store accumulator into 40. 360 store. 370 is a new section. 380 is, oh god, I hope I've remembered to save this. Right. We're loading the accumulator. 390, now we're storing again, of course. We're just moving stuff around. 400, now we're loading the accumulator with 0. And we're going to store that 0 into icax2.x. I'm sure surprised there's no way to just store a literal number. 420 jump subroutine CIOV. 430 new section. Oh, good, they tell us now save it, we'll remember. 440 load accumulator with put char. 450 store accumulator into ICCOM X. 460 new section. 470 load accumulator with text buff and 255. 480 store accumulator into IC ball X. 490 load accumulator with text buff slash 255. 500 store accumulator to ICBAH comma X. 510 return to subroutine. 520 new section. 530 label PRNT. 540 load the X register with IOCB2. 550 load the accumulator with buff len and 255. 560 store ICBLL comma X. 570 load accumulator buff len slash 256. Oh guys, I typed David, I'll look at what you said in just a second, but I noticed I made a typo in line 490. This should say divide by 256, so I'm going to do that again. 490, load accumulator text buff, 490 slash 256. Okay, 502 is wrong, it's 520. You're right. How do I get, well, 502 doesn't hurt, but you're right that we need a 520. I don't know how you delete like a line. How do you remove a line? Do you just do 502 like this? So what'd you say earlier? Trying to learn as we go. Is there a reason we skipped over 150 and 160? No, this is code like that they said, we're asking you to type it in, we'll explain it later. But I'm guessing either that when they wrote it, they thought they might need more stuff. So what are you looking at? 5 at 150. I don't think there's necessarily a reason, or maybe later when we use this, they're going to add some more stuff in between. So no idea. They kind of asked us to write this code without. Were you here when we started? They said something like, I'm going to pull a very sneaky trick. I'm going to ask you to type up and store on a disk a program you haven't yet been introduced to. And then they said, don't be so mad. Don't be too angry at me. So we're trying not to be angry. I was angry, but we're almost done. So what are we at? 570 here. Now we're doing assembly, Atari assembly, in case that wasn't clear. 570. So the next one's 580. Store accumulator to ICBLH, X. 590 is jump subroutine CIOV. 600 is return to subroutine. 610 new section. 620 is text buff is equal to star. This is a label. It looks like, I don't know, maybe 630 new section. 640 star plus bufflen. 650 660 dot end. Oops, 640 I did wrong. It should have been 2 spaces. No, that is 2 spaces. I did it right. So let's save it first. So we'll do list is to print it. God, I almost removed my program. List D2 to save it in drive 2. And what did they call it? Maybe it's print SC. Here it is. Print SC. prntsc dot source. We'll save it as a source file here. List will print, yes. Okay. So now we will just list it on the screen and make sure it looks right. And let's try to assemble it. See if it fails. Alright, it seems to have worked. You can assemble its object code and save it on disk under print screen object. I forget how to do that. I think that was with bsave, or is it just save? 1 second. So there was bsave differences, max 65, bsave instead of save. Bsave, blah, 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 replace start and end, bload. So what does just save do? That's what I don't understand. Bufflen, COV. See, I don't know what the end of the file is. Damn it. Let me try typing that again. Maybe it'll tell us. 00 5000 symbols. Bufflen. Bufflen is the first. Yeah, this is Bufflen is where it starts at 17. And then print is one of our labels, right? Yeah, that was not the end of the program. Well, we don't really know how to save it. Maybe save just does it. No. It doesn't matter. We've assembled it. We're okay, I think. Then there's another program I'd like you to type and assemble. It's the one we're going to be working with for the rest of the chapter. Okay. So I think if we go back here to CP, we should see our code in D2. We have print screen. So if I go back to the editor, max65420, and I list, I see nothing, then I can do enter D2 print screen dot source. Is that not what it was called? Print, oh, SC, print SC. So let's go back. Enter D2 print SC dot source. This should I can almost type printsc dot src. There we go. It loaded. Now if I type list, there's our code. And if I assemble, it assembles it here. Okay. Now we have to type in this one. So we're going to type new so that we have the new code. And we're going to type this. 20, the visitor. 30, 40, no, 35. Text buff is equal to $5041. 40. Open screen is, oh God. Open SCR. I'm sure I must have made an error in the other code because I just make so many typos. Print, see, like that. Print line is equal to $5031. 70, 80. This is telling it where the program starts in memory address hexadecimal 600. 90 is a new section. 100 text. Is this one space, right? Yeah, that's one space. Text is a label. Dot byte. $54, well, hex 54, hex 51, hex 4B, hex 45, 4B, 4520, 4D, 4520, 2 spaces byte, hex 54, hex 4F, hex 20, hex 59, hex 4F, hex 55, hex 52, hex 20. Line 40 is misspelled. Open SCR 5003. It looks right to me. Maybe this was while I was misspelling it? Or you mean in my previous code? 120 byte 4C 45 41 44 45 52 21. 130, 140, Visitor. Oh my god, why are we so leet? 160, load the X register with the literal 0. 170, this is loop is the name of the label, it's not a keyword. Load accumulator text comma X. So it's probably going to look at this text section here and start with the first byte, which will be 0, which is 54. 180, store into text buff comma X. Store accumulator, the value. Yeah, I don't know what that is. Store into that address, right? Oh, text buff is here, 5041, but offset by X. Okay, so we're just basically doing a copy by loading this section here, and text buff is where we're writing to. Then we increment the X register. SRC. Oh! Ha! Sorry, you're absolutely right. SCR equals 5003. Thank you so much. I think I'm dyslexic, honestly. But not so dyslexic that it was so obvious. CPX23. Compare with the X register 23. I think. If it's not equal, branch not equal to loop. So as long as it's not the number 23, just keep going, I guess. I see, because X is basically going to increment. These are probably 23 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Yeah, that's why it says 23 here. We're just basically incrementing, so it's a for loop from 0 to 23. Or 0 to 22, really. Branch not equal loop, so it'll just keep looping until it's X does 23 times. And otherwise, we jump subroutine open SCR. Jump subroutine PRNTLN. Ah, these addresses are subroutines, and probably we filled these addresses in this code, 5003. Yeah, because you see, like, it can calculate based off the 5000 here. And it probably knows, like, hey, if we're starting at 5000, then this open screen routine must be 5003. Because this is, yeah, I'm guessing. It's funny how they have to do this manual addition, and print line is going to be 5031, and print line is here 5031. Wait, print line 5031. It's probably this, even though it's not that same name, right? Because here's open screen, and here's print. All right, anyway. Infin, jump, infin. Infinity, this is the label infinity. Jump infinity, which means just keep looping forever here, because it's just going to jump back to itself. This program is called for reasons you'll soon discover. The visitor. It's a program designed to print a cryptic message on your video screen. Well, let's save it first before we lose this. And saving it is list drive 2. And they called it like VizTor, right? Let's see if we can assemble this. Does it work? Oh, undefined label. Undefined label. How do... I don't know how to see the... How do you go up? How can I see what it was? Like, it just scrolled off. Oh my god, I don't know how to do this. I can probably look at the undefined label. Oh god. So it's probably right before print line. Right here, right? GSR print line. Let's see here. Let's do a list again. JSR open screen parent line. BNE loop. This is loop. Open screen. 40. There, what is, can you do it like this? I wonder how to give it a list. In Max 65 for Atari assembly, how do I list a range? How do I use list with a range of line numbers? Comma. List 10, comma 40. All right. So what was it here? Loop. Where's the others? All right, so we're using BNE loop. Loop's right here, so I can see that's correct. Oh, I typed open screen wrong again. David, you're so good. I'm the worst at this, right? This is why I need a real compiler, I think. Did I do something else again? Is this what it means, like with the question mark maybe? It doesn't know what that means. Open scr. Open source. Just kill me. Just kill me. There we go. All right, so we saved VizTor. You can run it immediately, just assemble it. The problem is we first need to assemble the previous one, so we have to load that. So we do enter D2, what's it called? What's the previous one? Print source list. We assemble this. Okay, so now all of this is in memory. And I think we already, I think the other one is there too. So visitor.source should also be here. The visitor, and then we can assemble this too, and it's in memory also. When you have the program typed, you can assemble the object code and save it on disk under print screen.obj. Then there's one program I'd like you to type. Wait, oh, we did that. Yeah, we did this already. When you finish typing the visitor, you can run it immediately. Just assemble it and load the object code into your computer. Then you can run the visitor either by putting your computer into debug mode and typing G617, or by getting into DOS mode and running the visitor with a DOS command. Visitor.source. Why is it an S here now? Anyway, after you've run and saved the program, you know exactly what it does. So now we can explain how it does what it has done. Let's try running it. So we go back here, and then we run our debugger, bug65. Oh, you guys don't hear the sounds, right? Now? Now you hear the sound, right? Right, it said to run G617. I have no idea what it did. It didn't do anything for me. That was lame. Here, let's try running it in DOS. 1 second. How do we run in DOS? Oh, you guys didn't see my, I left the browser on. Yeah, well, we want the browser now, actually. The browser, we had how to run from DOS. Here. D1 run. So we just type in run 0617. I think it was 17, right? Yeah, 617. So let's see if this one works better. Does nothing. I feel very ripped off. It probably should have done something. I don't know. Let's figure out how to save it as an object file, but I don't think I did anything wrong here. Life is hard. So we're going to load visitor. What, visitor.source I called it? No, it's D2. This program begins on line 5000. EOL 9B, bufflen 23. So the first thing here is skr name. So when I assemble this, visitor, something seems weird here, right? Because it has our old code here. Let me do a hard reset of the computer. There we go. And we'll do max65 here. So we'll kind of do it from scratch. Enter d2 visitor dot source. We have the source now, and now, oh no, I should have, it's the other program. max65420, enter d2, what was it called, open screen, print screen, print screen dot source. We list it, we assemble it. This is all the code that gets assembled. The symbols are here, so text buff equals buff len. Print, here's print 5031. And here's open screen. Where's open screen here? 5003. That was the same code that we saw here, right? 5003, and print line should be 5031, 5031. So they match up here. The numbers match up, so that's good. The only problem with saving is when you save, you're supposed to know the last memory address of the program, but I don't know it by looking here. Well, anyway, let us now try loading visitor, because this should be loaded in memory. Alright, so now both of these are in memory. I go back here. Now when I run bug65, I should see code at 50050, what was it, 31 or something? What 5003. There should be code there. Oh no, it's totally empty, which means that when we've loaded the second program, it wiped the first. I see. So we've erased the program. But here we should be fine. Let's look at print 600. This is all empty too. How come all of our code just like isn't loaded once I'm in here? Like nothing's in memory. Did I type in 600 wrong in the source code? No, it says 0600, which is basically the same thing, right? Yeah, it makes no difference. Yeah, it's the same thing. So when I assemble this, this code should be let's see. It says BizStir is in 617 and text is at 600. So we should at least see something in 617 where the code starts. So let's print 617. I don't understand what's going on. 617. We're totally empty. I know what's going on. I remember that for Mac 65, we have to give it a compiler directive called opt obj. Otherwise, it won't load the memory. It won't load the assembled stuff into memory. God, why? Why would they? Why would they not remind us of this? So, hey there, Mabel and Krisky. Like, we're not doing basic, we're doing 6502 assembly programming. So what I'm going to do is make sure I don't make the same mistake again in the future by adding this into our debugging section here. Make sure to add .opt .opt, I forget what it's called, directive, whatever that, yeah. All right, so when we look at for opt, you need opt obj. It's opt space obj. All right, so let's go ahead and edit our programs to have that. So Mac 65420. We'll first load the first one. Which was it? It was called print screen.source. And in here, print screen.source. We want to put it right before this. So 45 dot opt obj. There we go. Let's see if this compiles. Perfect. All right, that's great. Yeah, and now I can save this. So list D2, and this is called print scr. I guess I'll make it a 1 maybe. I hope it can add a letter to it. Okay, so it saved that. And now let's load vistor.source. Let's list this. And we see 80, we have it. So right before 80, we'll add in a .opt obj. We'll try to compile this. It's all happy, and now we can save this. This is list d2 vistor2.source. And now we go back here and we go to bug 65. Now when I list 600, yes, we actually see, here's take me. You see, like, this is going to be, we actually did this kind of once before. Actually, we figured out on our own how to make this program work. A different program, right? Now that you mention it, it does read more like assembly. Yeah, it doesn't have it has a lot of three-letter things like compare X register, branch not equal, jump subroutine, right? So anyway, let's try to run this thing. G17, take me to your leader. Look at that. It printed it to its screen, and probably it's gone into that infinite jump loop at the end. You see here? Infin, jump, infin. So, thank God we got that working. You know that it took us over an hour to do this? Crap, I have to get going soon. I have choir tonight. I'm in a Japanese choir. I don't speak or do anything Japanese, but they give us like all the songs. Well, it's half of the choir is Japanese. They sing, they get the sheet music in like Japanese. And then someone translates it to like Romanji, so you can kind of just like pronounce it out. And so yeah, that's what I do. So I don't know what I'm singing, but it's a lot of fun. I love it a lot. And today's like the like 13th year anniversary for this choir in its existence. So like there's going to be a party, we're going to drink, we're going to have some champagne, and then all the Japanese people bring like something that they make from home. So it's going to be matcha stuff and all that. It's so good. All right. So, see, I think I have enough time to read a little bit more of this. Just so that we've run the program. And now let's try to understand what just happened a little bit. I swear to God, though, like the stress of running, I mean, it's not really stress. It's just like so frustrating when like you use this like old tech and these books like oh they don't mention they don't mention stuff like make sure you use the option obj thing like there's so many ways in which you can shoot yourself in the foot, you know, and it's kind of crazy. Have you guys done what is assumed knowledge at the time right now? So the thing is like we've been doing this book, we're on page 113. And the book starts like we've read this. If you go to my YouTube page, it's in my like link or profile or whatever, right? And you can look at the Atari playlist. We started from page 1. And I know nothing about Atari. I know nothing about like 6502. So there's all these books that are like, "Oh, here we'll teach you about 6502." But then you can't actually program anything because you have to program on the Atari, right? So the 6502 books are great, but you kind of have to know how to use an Atari. And then there's all these Atari books that won't teach you any machine languages, assembly language. So it's like this is I think this is the only book I've found where it kind of teaches you both. And so like we started out like basically learning about what what assembly language is, what's a CPU, like really, really basic stuff, what RAM is, and yeah, there's no knowledge kind of assumed or any programming stuff, which means that the beginning was kind of slow. But yeah, now we are, what, halfway through the book? Not quite, but getting there. And we're actually writing assembly code. Yeah, yeah, the book is pretty good. I think anytime you deal with anything back from like the 80s, like it's not always going to match up great. Like it's not like these days where you can be like, oh, make sure you like run this, release from GitHub and make sure that you now have this exact version of the compiler. And if you don't, like you can just like I use Nick, so I can just go back and get that old version or whatever. But it's like all easy to match everything up. But like back then, it was like, who knew what kind of computer you had, whether it's an Atari 400, 800, 800 XL, whatever, right? How much memory you had, which specific version of the assembler you're using. So it was like a lot harder. Anyway, since we actually got it to print, this is like actually, I changed my mind. This is a good place to stop. We've been on it. We've been at it for a little while. I can get dressed comfortably, easily before going out for choir today. So we'll stop here and then we'll learn about the magic of how this actually worked in the next session of Atari 6502 Assembly Language Programming. So every session is a little bit frustrating, a little bit annoying, especially because I can't type anything. Thank you so much. Who was correcting me? Was that David? David, thank you so much for helping me. You probably saved us like 20 minutes at least of finding out what like things are. So thank you for that. And we'll keep going at it. You know, one thing I should note that we should figure out is like when assembler like it tells us all this stuff when it's assembling, I don't know how to go back up. Like it's all scrolling on the screen. So there's probably a way to do that. I'm going to make a little note here. Like let's put it in our little gist stuff here. And if any of you guys know, or someone who's watching this VOD later, questions. How can we see the output of ASM? Example, scroll up. In Max 65. So that's a question. If anyone has the answer to that, please do write a comment or somehow ping me on Discord or whatever, because that is a nuisance. Yeah. Otherwise, thank you for tuning in. Do subscribe or whatever, follow, that kind of stuff. And I do videos on other languages. I've done some on Rust, Gleam, Nix, which is also the Nix OS distribution for Linux, but it's like programming with Nix and how to use Nix itself. And what else did we do recently? COBOL on the IBM mainframe, ZOS. That's way worse than the Atari. But it's fun. It's fun being frustrated. Yeah. And we got to go back for Haskell sometime. All right. Thank you. Talk to you guys later.